Okay, welcome to the SDC weekly address for the week of January 17th, 2010. And today I'm going to go over several topics. I think to begin with, we'll correct some misportrayals from previous addresses here. To begin with, I want to go over my little talk about consonants. So this has to do with music and the PRE table and these vibrations that are helpful and all this stuff. And the way I portrayed it before was basically totally wrong. Well, not totally wrong. It's just one statement in particular about how if you have two waveforms, wherever they cross each other, that defines wavelength or something. No. Okay. So we'll do this over again. Hopefully a little bit better. And I thought of some more useful analogies maybe that'll help clarify the situation. So in dealing with music, and this also applies to any kind of alternating current, and I'm sure if you're into electricity and stuff, you'll see things like this. But we're going to start with just a line, okay? Now, what this bass line represents is, in terms of music, in the air, it represents normal air pressure. Because with the waves that are in the air, you get small instantaneous variations in pressure that are actually what our ear interprets as sound. It's one way of saying it. So if there's variations, you have a zero line, and you go above the zero line, you get a little bit higher pressure. Below, you get a little bit lower pressure. And so when you get a waveform, it'll go above and below the line, like a simple sine wave. It just, I'll draw it here too. A simple sine wave, it's called that because it's defined by the sine function. If you took trigonometry or whatever, you'll remember that, maybe. But a sine wave, it just snakes above and below the line in a very smooth, undulating fashion. Actually, a perfectly smooth, undulating fashion, unlike what I wrote or drew there. So that would be just one wavelength. It goes above and below the line just once. And then it would repeat. That's just basically one period of the waveform. And the whole idea behind a frequency in sound is that you get basically that. If there's a continuous tone that doesn't change, you get that same exact waveform every single time, every single period. So they're all strung together smoothly, and it just never ends. And that's your simple tone or a sine tone. And then if you wanted to double that frequency, like play an octave higher, the same distance would describe two periods. So you would go all the way up and down, and then again all the way up and down. And I guess I should draw that one. Yes, I know this is very crude. I should have something set up so that you can see what I'm drawing in real time, and maybe if I'm really cool, I can find some tools like that and get some cooler video. But so with this kind of solid line, what I tried to draw was a waveform that's double the first frequency. So notice that for part of the time, they're both following basically the same path, and for part of the time, the other half, they're opposite. And if you actually play these two in air, you'll get what's really the sum of those. So where they're going over the same spot, like they're going the same way, trying to point, they're both following the same basic path here, they would actually sum at this point and be like double in height, or double the air pressure. And then the negative pressure would be doubly negative down, or not there, at a place where they both go below the line together. And then in between, where they're doing opposite things, they would start to cancel each other out. So you would get a composite waveform, and I'm not going to draw all that out. Maybe I can do fancier graphics later. I guess what I'd like to do is just do a little website that describes this kind of thing. And there are probably others out there that are just as good. But the whole idea is when you play two frequencies together, you basically create a composite waveform in the air, in your medium, so that there's no difference between those two pitches, waveforms being generated individually and summing, and just generating the composite waveform in the first place. And the whole reason I'm going into all this simple physics or whatever is that it has to do with constructive and, well, this constructive and destructive interference in regular patterns has to do with consonance and dissonance. So if the waveforms lock, when I say something locks, that means that there are these points where they both cross the zero line together at regular intervals. And if it's a simple octave like this, like it'll be every single period of the original, of the longest wavelength here, the longest waveform. That's where they'll cross. And the basic idea is you get two waveforms playing together, making a new waveform that harmonizes with them both, is following the same basic pattern of repetition. And then the subdivisions of repetition that you end up creating in your more complex waveform are still very simple mathematical subdivisions, regular mathematical subdivisions of your initial undulating pattern, your initial waveform. So I guess that's the most physical way to describe it. If then on the other hand, so that's consonance when you get, and it doesn't have to be just double. It could be you take your original period and divide it into 3 parts. So basically when you divide your wavelength into multiple parts, you're taking the frequency, like the number of cycles per second, and multiplying that. So like what we did here by making a waveform that's going twice as fast, we actually basically multiplied our frequency. We multiplied the initial one by a factor of 2, and you can multiply it by 3, 4, 5, and that's what I mean when I say integral multiples, integers, the integers starting at 1, 2, 3, and going on up to infinity. So there's basically a countably infinite, you can go up, count up as much as you want, so a countably infinite number of consonances for any given pitch. And also, pitches that are somewhere along that line, along that series, within that series, are all consonances of each other. So, I don't know if this is a good time to bring that up, but an example of that is if you take the multiple of 3, like 3 times your given frequency, and say, okay, we'll pretend that's the main frequency. Well, all the multiples of that new one that you just chosen are also multiples of the original one you chose. But just by nature of the fact that you started with something that's an integral multiple, just a simple integer multiple of your original frequency. And so you can get all these, there's countably infinite numbers of families of I guess you could say series contained within a series of integers, depending on where you start. And that is relevant because the ear, when you listen to tonal music, has this idea of a tonal center, as in what key are we in? What's the root note? The note that when the melody returns to it, it feels like a resolution. And that's typically the note that all of your melodies are kind of leading to and converging on if it's traditionally constructed tonal music. you can change that tonal center, and that's called modulation. And when you do, you're basically, hopefully, moving to another integral multiple within this overtone series, or at least that would be like there's a name for that kind of modulation where you don't really change any of the consonant pitches, you're just changing your tonal center. So for you musician people, that would be like a modulation from C major to A minor. So it's a relative minor of the major. Those kinds of modulations. And I'm completely rabbit trailing here. That's basically irrelevant to what we're getting at for therapeutic effect. Just the simple idea I'm trying to get at here is that there's a physical basis, in physics, the physics of sound, for the definition of what is a consonant interval, what is a harmony, as opposed to what is a dissonance. So if you have two pitches that don't ever match up at regular intervals like that, you'll always get a regularly repeating pattern when you play any two pitches, and those are called beat frequencies or difference tones. But that difference tone that you get, that repetition that you get, might not be any kind of simple multiple of your initial wavelengths. So I guess that's the real definition. If your composite waveform that you get when you add the two together, if you take however far you have to go before it starts to repeat, that composite waveform, if that doesn't match up with, as a simple integer multiple of your, or fraction, I guess, because we're thinking about this the other way around, of your initial frequencies, then it's what we call a dissonance. And if you play that through distortion on the guitar or something as a chord, it won't lock. It won't have the same kind of very stable, very defined sound. And in normal music, it's more of a subtle effect, I guess, but or not so subtle, depending on how sensitive you are, but it will sound better if things are in harmony. Of course, in music, it's all about, it's like drama, you have this whole struggle between things that are in harmony and are not in harmony. So if all we did was play things that were completely in harmony and never changed anything at all, well, that would be just like playing a simple chord and letting it go on forever. And when it gets to therapeutic biology and things, that obviously doesn't work, as we've seen from what I've read, as they've seen in experiments. The cell will get used to repeating stimulus like that, and the therapeutic effect you get, or even in a tissue, I guess, the therapeutic effect you get will start to diminish. So when this relates to the profound relaxation table, like Paul Solomon describes, same rules apply, apparently. Now, I haven't verified all of this as far as, is the sonic harmonic signature of a healthy organ, is that always like a harmonious chord, as in, are all these frequencies that it emits simple integral multiples of some fundamental frequency? Maybe, maybe not. I definitely, at this point, I've not looked into it enough to figure that out. From what I saw immediately in the Dillawar book here, that seemed to be the case, and it would make sense. So I guess as well as boring you to tears with this 15-minute long description, I'm also trying to inspire you with the idea that I think there are some really good things to come in this researching the effect of vibration on health and the cells and things, because it seems like it really relates to the nature of tonal music and harmony, or at least it relates to the physical basis behind tonal music. There are lots of conventions that arose in tonal music over the centuries that were just fairly arbitrary. And of course, anything is like that are just stylistic, basically, probably don't have anything to do with therapy and healing, which would be why Paul Solomon could easily recommend New Age, or what he called free form music, as an alternative that would be just as functional to using largo movements from the Baroque period, which is one thing he described, or Brahms or Wagner or things like that. So, lots of interesting stuff there, and of course I can't wait to get into it and share discoveries with you and things like that, but that's enough of that topic for now. Okay. Yeah, and I had some other examples, but that we'll leave that be. That's enough. The next thing I wanted to touch on was, okay, at the end of my supplemental lecture or address, whatever you want to call it, I had this tirade about how it really bugs me when people act like they know something and they don't really understand something, but they spout out the words and as if they do. And of course, immediately after saying that, I was reminded of this concept in the readings, and it's not just limited to that, of course. It's a very simple truth that whatever most annoys you in other people, you've got to look back at yourself and see where you're doing that, because it's probably a characteristic of yourself that really annoys you, but you're unwilling to face or unable to see or whatever. So yes, I realize that often I do have a tendency to talk about things as if I have a more complete understanding of the topic than maybe I really do. So one critical area that came to mind immediately was when I talk about string theory. Okay, now understand, string theory, by the way, for those of you who don't know, is part of quantum mechanics, as in the physics that deals with structures smaller than an atom, or the makeup of the nucleus of an atom, and all the things that make that work and things. Basically what you see when you go smaller and smaller. That's my very crude layman's definition. But anyway, so string theory is one of these theories that has to do with that, and I like to banty that about as if I'm some kind of expert, and realize I'm definitely not a physicist by profession or training. I have taken physics courses and things, some of which I did not do so well in, some of which I did okay in. I found physics very fascinating and also very complex, and my biggest downfall was probably mathematics. Math is something that I've always been able to do and do well with effort, so it's definitely not this built-in talent of mine by any stretch of the imagination. So, so what I'm trying to get at here is my understanding of string theory is very simple and hugely oversimplistic, and I'm sure anyone that really knows about it would flat out laugh if they heard me talk about it, because basically my understanding of string theory is limited to this. Okay, from what I've read, it appears that there's a search for some kind of unifying theme or set of particles that make up the subatomic particles that we know about, like the quarks and mesons, and I'm not even going to get into that as if I know what I'm talking about, because I don't. Sorry for the interruptions there. But my understanding of string theory is simply that there are these strings of, I guess, energy, in the sense that everything subatomic seems to be at some level, fundamental level, made up of energy the more we look. So basically configurations of energy that have to do with resonance and vibration, and those things, those characteristics of the strings, among other characteristics, I guess, of like their dimension. Are they a manifold, something complex? Are they a simple string? What is their length? What is their dimension? Are they just points in space, or one-dimensional, or, those kind of characteristics define what type of subatomic particles you end up with, which in turn define what atom is that, how many protons and neutrons are there in that nucleus, and therefore which element is it, and et cetera, et cetera. But so the idea is that from my very, very simple understanding, without looking anything up, is that vibration, in some sense, obviously not vibration in the sense we think of a guitar string vibrating and creating sound, but in some unbelievably small microscopic scale, in some type of dimension or meaningful sense, these entities do vibrate, and maybe some laws of harmony, like the ones I'm talking about with sound here, and consonance and resonance, where you have one vibrating entity causing another one to vibrate in a similar fashion, perhaps those relate to the very building blocks of matter at some level. And the reason I bring that up a lot when I'm talking about these readings is that the information I've been able to gather from, like, especially the Paul Solomon source and perhaps some of the Douglas Cottrell stuff, Ross Peterson may have touched on this a little bit, but I don't think so in the 8 readings that I've heard of his. When they talk about creation and what solid matter is and what this 3-dimensional existence we're in, what it really is, they start talking about things that in terms that sound similar. When they're talking about matter having rates of vibration, and that rate of vibration determining what dimension you're in, and how you have to change the rate of vibration for the entire entity. So I assume it would possibly be a subatomic rate of vibration of strings that make up the atoms in that entity, or the subatomic particles in the atoms in the entity. Perhaps all of those, the vibration of all of those in whatever sense they vibrate, would have to be modified uniformly in some direction, as in an increased rate of vibration or something, or who knows, in order to shift dimension or travel between the dimensions and things. Because these are things that the readings claim is possible and even have been done in the past in Earth's history in cultures that knew a little bit more about them and were able to manipulate these characteristics of matter and things. So that what I'm trying to point out there is my understanding of string theory, quantum mechanics, and subatomic particles and things is very simple, very basically a high school level or amateur, I read it on Wikipedia level, and even that, definitely didn't understand everything I read on Wikipedia. I think it's incredible how these science and medicine articles and things on Wikipedia, like it has to do with anatomy and medicine and things, they're getting down to, seems like, medical textbook level. And when you get into physics, it's right down there. They have all the basic equations in there, and it looks like a lot of the physics textbooks that I read and had to deal with in high school and college. So I think that's cool that people that really do know about this stuff are contributing to these things. And so now it's even beyond the level that I can understand easily when I sit down and read an article and stuff like this. But I try to glean whatever I can. And obviously a lot of these things are still theories and unknowns, so that also adds complication to it and may make things more difficult to understand. So take things I say like that with a grain of salt, and I'll strive to clarify the limit of my knowledge on a topic like that when I just whip it out and act like I'm some kind of expert. Now, on that note, though, however, it would be fantastic if we could get someone who really was an expert on string theory or other theories of or variations on string theory, dealing with quantum mechanics and the physics of the makeup of all matter and things. If we could get some real experts on that were halfway interested in these readings to come and talk about it and stuff, or have some kind of interview or something, that would be really cool. Or just fire off a short note in the comments on YouTube or something. Who knows? Okay, so that's that. Next thing I wanted to deal with is, like I said, when I gave my little review of this Delaware book, I said, well, maybe I'll talk about it more in depth when I've had a chance to read it again. So here we are. It's Sunday, and this this is all the farther I've gotten. This little bit here. I got to page 12 on my rereading. Well, and there's a reason for that, because he started mentioning some names of scientists and stuff, so I started looking all this stuff up, and it just, took forever. I was downloading papers and reading articles and all kinds of stuff. And it may be like that for this entire book, because the author he throws out lots of theories, lots of names of researchers in mainstream science and alternative science and things, and so it's really kind of a gold mine for all this possibly related and other information. It's like a starting point. Because, for instance, he mentions this guy I'm going to talk about, Gurwitch, in the context of his mitogenic radiation. So this would be, I guess, low-level light photon emission by living systems, which is something that's starting to gain momentum again in legit science, I guess. Like I've said before. But when I read up on this guy, I found another topic that he was really associated with and even better known for, I guess, in some sense, that I'm really going to talk about here. And this guy, the author, doesn't hit on that. And I think he really missed the boat, because it was possibly even more relevant to some of the things we're talking about here. But anyway, so we're talking about Alexander Gurwitch. That's Gurwitsch. And I think Gurvitch might be how it was really pronounced. He was from Russia, moved about through various places throughout Russia in his scientific career. But apparently a really famous guy in developmental biology. So that's the field of biology that studies how life forms grow after fertilization. So basically you have your sperm and egg cell coming together, and then you have one cell that's like a fertilized egg. How do you get from that one cell to being something like us, that's a full-blown multicellular eukaryotic organism that's insanely complex and has, billions of cells or more? How do you get through that process? And so most of the study of developmental biology, or a lot of it, is in gestation, in the womb, like with mammals, because a lot of the stuff and the most interesting stuff happens in those early stages, when you get from one cell to just a few cells to a few more cells, and how those start to form the intermediate stages of what later becomes a full-blown human baby or puppy, or depending on whatever organism you're looking at. So developmental biology, and Gurwitch was working, I want to say, around the turn of the century and then into the early 20th century. I guess I could, instead of just trying to wing out completely erroneous dates here, I can. So his lifetime was from 1874 to 1954. So basically most of his career was in the 20th century, right at the beginning of the 20th century and on. And that's important because there are a lot of things they didn't know in biology back then. Most importantly, they didn't know how hereditary information was transferred, as far as at the molecular level, how was it transferred. They knew it had something to do with chromosomes. They didn't know if those chromosomes were just made up of proteins, and so there's these theories that just proteins encoded genetic information, and all kinds of other competing theories, and they didn't really know. And so there was still a lot of momentum, I think, to this idea that there was some kind of life force in biology, in biological systems, that was kind of unseen, but a little bit extra, something beyond just simple nuts and bolts chemistry. So that, I think in the view of a lot of these biologists at the time, they would tell you that the human body, for example, cannot be explained, and its function cannot be explained simply in terms of chemical reactions. As in, if you just kind of add up the effects of all the chemical reactions that are going on within the cell, you get the functioning of the cell, and you get the functioning of the organs and the tissues in the organism, which is very much the view today, that it is all materialistic, and there is no magic life force, no spiritual fields and things. But of course, coming from the perspective of these readings, that's all they talk about. From their perspective, the material body is just a expression. It's like a projection, a creation of a spiritual idea and concept, and also that we all have a soul and a whole other dimensions to ourself that transcend this three-dimensional reality. And of course, dealing with how the mind is supposedly capable of manipulating energy and turning that into solid objects, three-dimensional matter, things like that. Those are the types of concepts you get from the readings, and when you apply those to biology, well, then you do get a picture that actually is kind of similar to what a lot of these guys held around this time, or at least this guy did, before more things were discovered. So, I know I'm kind of butchering this, but just bear with me. So Gurwitz spent time studying embryos. He would study under the microscope very small groups of cells that start with a fertilized egg, and how those cells organize each other. And the attempt was to discover how on earth are these cells determining how to go to the right place at the right time, how to turn into the right type of cells at the right time, orient themselves in the right way. And even now, that's one of the most fascinating studies in developmental biology, is how all of that takes place. Now, there were some things that Gurwitz noticed when he looked into this that were just flat out fantastic from his point of view. And the really core observation that he made was that when you have a small number of cells that are going to be part of a given tissue, let's say, with a given curvature. I think he's looking at the neural tube formation or something, and epithelial tissue. So this would be like the tissue lining that would turn into tissue lining the nerves and turn into the brain and things. And but very early on, you basically start with something that's like a sphere, and then the thing will like flatten out and form what's going to be a neural tube. And so you have this very gradual unfolding of a contour, and that's being formed of all these little cells that are going to the right place and orienting in the right way, and then dividing and things, and gradually changing and manipulating and forming this ever-growing structure. What he noticed was that those cells would, when they got to their given place, they would orient themselves according to a surface that they were going to form in the future. So let's say they were going to form this nice curved surface, but at the moment they were just this kind of jumble of cells, so they'd be all jumbled around willy-nilly. But one of the first things they would do is orient themselves so they're pointing the right direction. So the cells that were going to form like the outside of this curve, they would be kind of pointing that direction. The cells that were going to form the bottom of the curve would be pointing this direction. Cells over here would be pointing more this direction. And those cells would orient themselves in those correct orientations long before that surface ever even formed. So there'd be kind of this noisy jumble of the cells, but all of a sudden they would be oriented in the correct direction before that surface ever even happened. And the reason that's important is that the whole idea from this materialistic viewpoint is that these cells are just touching each other and going by what they can feel the cells around them doing and the pressures from the cells around them, using those things as signals to turn a certain way and things like that. And his point was they were actually turning in a way that had nothing to do with the other cells around them, but it had to do with how they were supposed to be turned later on in the structure they were going to form in the future. And he made lots of observations like this. So very quickly he started to, basically the simplest explanation to him was that there must be some kind of field in space, like a force field that was the shape of this surface that was present, and these cells were sensing this force field and orienting themselves accordingly. Now, if you've been paying attention to what these readings say, I don't know how much I've touched on this kind of thing, but maybe not enough, but particularly this book. In this book, they're taking pictures of things that aren't there, in the sense that they use like a seed of a plant, and they can get a picture of how that plant will look when it flowers and when it germinates, how different parts of that plant will look in the future. While currently all that exists is a seed. Well, that type of thing, I guess that's what I'm really getting at. I'm not sure how much that type of issue has been talked about in the readings. They just seem to talk about the basics, as in there being a spirit body in the spiritual realm and things like that. They don't really deal with development. Maybe there are some times when that's been asked. Those would be some great questions to ask, however. Like to ask Douglas Cottrell, hey, were these initial theories of this Alexander Gurvich that, was this initial theory that, hey, there's some kind of field that is preceding this development, that the field is changing and the cells are basically following the organization of this ever-changing field. Is there really a field like that that's we're not currently perceiving but really governs developmental biology? That'd be a fascinating question to ask directly. But anyway, it really seems so from everything these people have seen, and from what I've read in the readings, it seems very consistent with this idea that things start out in the mind first, or in the spiritual realm first, or as ideas first, and then they get manifested in reality. So that Andrew Jackson Davis goes over and over this, so that the idea is what is important. The idea is what is real. The thought is what is real. And Paul Solomon, he hammers that again and again. And I think Douglas Cottrell does as well. The thought is what is important, way more so than the result. When we talk about illness, they talk about thoughts and emotions, how those are these overlying forces that are really creating the conditions where those viruses and bacteria are starting to take over and your immune system is no longer keeping them in check like it's supposed to, or those cancer cells are always taking off and growing willy-nilly instead of being subdued in their growth and then taken out by your immune system. And why is that happening? Why is that balance getting altered? Well, the description from the readings is that there's an overlying force of thought, of emotion, of spirit, if you will, in this other dimension that is changing. And since that thought world or spirit world really is the reality, and since the material is just a projection, well, when things change above, then so below they change as well. And so that's the whole concept you get in these readings, and the whole concept they keep hammering home is if you really want to treat disease, treat aging, things like that, you have to treat them at the source. And the source is a spiritual cause, or a higher dimensional cause. It isn't really these nuts and bolts interactions that we keep looking at. In fact, we're looking at the wrong end. When we look with modern medicine and things, we're always looking at what are those viruses and bacteria doing, and what's happening at the molecular level, and why aren't these genes turned on or when they're supposed to be, or why are these other ones turned on when they're not supposed to be, and what are the metabolic pathways that are governing this or that. And according to the readings, we're looking at this completely the wrong way. And so, by the same token, in developmental biology, we would be looking at things in entirely the wrong way. And according to the discoveries made by Delaware and others in radionics, we are looking at things entirely the wrong way. And what they're finding is that when you address things at that higher level, or approaching that higher level, you can get better results. You can get treatment from a distance and things, and all these other things that seem to be miraculous. So, Gervich, he basically had this theory of morphogenetic fields. It's still a core theory in developmental biology, but the meaning has been changed. As he went through his life, and as other scientists kind of had their way with this theory, and the materialist mindset gained more and more power when we discovered how the genetics really worked in the DNA, and how you go from DNA to RNA to protein. As that all started to happen, of course, any kind of mindset about there being invisible force fields and things was going to evaporate very quickly. And his theory died a very slow death, in that even he was very slow to yield all of these tenets about these force fields and say that they're all crap. And developmental biology was very gentle and accommodating in the way that it modified its viewpoint. So now, from what I've read, I'm definitely not a developmental biology expert, but from what I've read, it appears that the stance is that no, there are no invisible force fields. There's just some really complex higher order probability statistics and mathematical relationships that are governing these interactions that wouldn't be immediately apparent if you're just assuming this is all simple cell-to-cell contact and signaling. So, in my personal opinion, I think what we're seeing there is two different ways of looking at the same phenomenon. Yes, the more you look at it nuts and bolts wise, the more you'll see that there are governing principles and mathematics and things behind it. But that's not to say that there's still not this overlying cause that really is in this higher dimension. It could be that is the way in which this field has its effect or something. I have no idea. Getting from one to the other. But it's not odd that we have discrepancies like this. Look, if you listen to especially all these modern guys, Douglas Cottrell and I'm pretty sure Ross Peterson, definitely Paul Solomon, what this all has to do with is bicameral man. The fact that we do have a split brain that kind of fights itself and argues with itself. So the way I think Paul Solomon's one, the way he says it was, everything that mankind invents is going to have to fight itself. Every discovery he makes, every theory he comes up with is going to be a theory where you always have opposites. You have action and reaction. You have things that have to fight each other. And by the same token, when we're talking about developmental biology like this, I think the theories that we come up with are going to be so tainted by our perspective, our bicameral perspective, self-defeating perspective, that the theories are going to be inherently self-defeating and full of this half-truth and very insidious kind of error that's almost impossible to ferret out. So definitely beyond my capability to simply point out whatever would be erroneous with the standpoint in developmental biology that says it's all based on simple probability statistics and mathematics. But that's not to say that there aren't errors there. In fact, I'm sure there probably are. So my point is that even though this guy, Gervich, gradually changed his viewpoint over time, and his theories over time, in some sense, and even though he only truly believed these were real invisible force fields back in the early days, in the early part of the 20th century, I think he could have very well been on the right track then, and thinking more clearly and more free of this bicameral influence back then, and could have been more inspired back then. He definitely does seem like a very inspired researcher when you read about him and his work. Inspired by intuition, very intuitive individual. So I think there's a lot to that, and it's very interesting that even a phrase such as morphogenetic field still survived to this day in developmental biology, in this horrendously materialistic mindset that we have currently in biology and the life sciences. So that's what I've gleaned from the book so far. I guess not much. There was also some talk of these emissions, and I did look a little bit more into the biophotons and ultra-weak photon emission that's currently being studied in mainstream science, and it still seems to be pretty much a fringe thing. There's just a few guys that are looking into it. Like in Japan, there's this one group that was looking at the human body and the ultra-weak photons it would emit. So they put these guys in completely light-tight, dark room and get this really highly sensitive camera and take images of them like at different times of day and things, and they saw that there were fluctuations in the patterns of light that were coming from them, and most of the energy was coming from the face and the head, most of the light, which is kind of interesting, and not as much from the rest of the body and things. But boy, really fascinating stuff to hear that, yes, there is electromagnetic radiation or photons are being emitted by these living systems, and that's just in the visible range. And the statement that was made in this book is that some early scientists in the early 20th century discovered that the entire range of the electromagnetic spectrum was emitted by living systems. And that's what I was really trying to find, and I haven't found it yet. So if you're really cool and you can dig this up, he refers to work at Columbia University done by I. Rabbi, P. Cush, and S. Millman. And if you look up Rabbi or Rabbi, whatever his name is, or Rabbi, I'm not sure. He's like the founding father of magnetic resonance imaging and nuclear magnetic resonance, which are these scientific methods we use to take pictures of atoms and molecules and people's heads and stuff, and you hear about an MRI. It's all based on the work of this guy, and he's one of the best known, most successful, most brilliant scientists in modern history, in the life sciences and things, and even in the physical sciences, I guess. But apparently, and reading some of his earlier work, it wasn't just about magnetic moment and things of these particles. It also dealt with particles emitting, molecules emitting electromagnetic radiation, and that has to do with when electrons change energy levels from one energy level of an orbital to another. If you go down, you'll emit photons, and then you absorb photons, you'll go up energy levels, things like that. So that, of course, makes sense. I know that's pretty common, or very simple aspect of basic chemistry, or I guess you would call it, or quantum physics at some very superficial level, is that that's how molecules work. If you hit them with just the right wavelength of photons, that photon will get, and it hits just the right part of this electron orbital, it'll get absorbed. So the photon disappears, and the electron orbital suddenly is at a higher energy level, and these energy levels are quantized, they're fixed. And by the way, I read something very interesting that I'd never noticed before when I was trying to learn a little bit more about quantum mechanics and these electron orbitals and things. The statement was made in Wikipedia, I'm sure this was written by a very competent scientist, that the reason that there are quanta in energy levels, and that energy is all quantized in molecules and things, is that, is at discrete steps, is that what sounds like to me the same reason you have these fixed harmonies, fixed consonant intervals in music. Like if you have a standing wave in a box, you can also have other standing waves that can exist in that box that are integer multiples of the frequency of that standing wave. And this has to do with the harmony I was talking about in the physics, where these waveforms have the same, midpoint or zero point where they cross the zero line. Basically, and so therefore, it's for the same reason in a resonant cavity, the only frequencies that can exist and resonate are ones that are perfect integer multiples of the fundamental frequency. By the same token, in a sense, you have some kind of frequency of vibration of your electron cloud in an orbital, or the electron, in a sense, is vibrating at a certain frequency in that orbital. And since this is also a type of standing wave in a certain sense, the only other waves that can exist in that cavity or orbital would be even integer multiples, or not even, but exact integral multiples of that fundamental frequency, of your fundamental lowest energy level. And so that gives you discrete steps. The only configurations of energy or wavelengths of vibration, or whatever, however you want to say it, that can exist, those only energy levels that can exist within the atom are those fixed integer multiple rates of vibration. So here we go. It's like the building blocks of matter again and again. Look, they seem to relate to music. And there were lots of philosophers I touched upon when I was reading about this stuff in history that had these kinds of theories about how the universe was based upon these rules of music, and how music was just kind of some outgrowth of the fundamental principles and laws that make up the universe. And wow, it seems like in some sense, the more we get into it, the more it seems like that really is the case, at least from my very superficial understanding of all this stuff. Wow, okay, so this is all taking a lot longer to go over than I thought. Well, I think I'll stop there, because the other thing I wanted to get into, and I think I'll save that for the next address, or maybe another supplemental address, is common themes in the readings. I don't think I've ever really gone over what are the basic, simple truths, if you will, the simple themes that are similar, that all these different sources agree on. And next time I'd really like to go over that in detail, and perhaps it'll take several different addresses to go over all that. So I might end a little bit early. I guess I will also try to, I'll keep you up to date as I discover more about this work of Delaware and radionics and stuff, and anything else, I'll definitely try to keep you posted. And if and when you discover anything else, definitely keep me posted. Feel free to just mention anything under the sun. I definitely may not have heard about it, and it could be really valuable. So, yeah, until next time,